Hello my dears, how are you all? So in the last class we did some torque slip characteristics and derived the expression for or the conditions for maximum torque, full load torque, right? So torque slip characteristics and effect of the rotor resistance on the torque, okay, for maximum torque, like etc. And we derived of the relation or the condition at which maximum torque occurs. Very important. That is rotor resistance R2 will be equal to S times slip times X2. R2 by S, X2 is equal to S. That is the condition. So by doing some problems, it may be very helpful. Okay, these relations are very helpful while doing some problems. Okay, so today's class we are going to do very important questions regarding the that torque equation and input power, output power, efficiency, and many more. Okay, so let's do one by one. So write a question, ideas. Write a question. Write a question. See, regarding this induction motor, the question will be very lengthy, right? Short questions also there, but question will be normally very lengthy. Which means we have to find a lot of terms regarding that, right? Input power, output power, slip, torque, etc. No? So normally I will write a question in very detail. Very lengthy question. Okay. So in your examination the whole question will not be asked, but a portion will be asked, right? A 10 HP 3 phase star connected induction motor having F is equal to 50 Hertz, 4 pole, 440 volt, stator, its full stop. Stator simply full stop. Okay, not stator. The motor operate at 1440 RPM. Stator core loss is negligible. And stator copper loss is 0.5 HP. Friction and windage losses. Is 0.5 HP. Find A. Speed regulation. We will do actually this A to F is there, F up to F is there questions. So the question will be up to this. Then we have to go for remove the upper portion and we will lose some data, right? It is easy to remember or recall me if actually I stop question here, right? A, B, C, D, etc. will be there. We will do accordingly. Not fully I am writing here, but after solving one A, we will do for B and we will do for C, etc. Okay, that is very easy. So first we have to find the speed regulation. See, a 10 HP, the power will be normally in HP or in watt. Okay, both it can be. So a 10 HP 3-phase star connected induction motor having Star connected induction motor means the stator is star connected, my dears. Induction motor having F is equal to 50 Hertz and 4 pole 440 volt. The motor operated at 1450 RPM. Okay, stator core loss is negligible. Okay, fine. And the stator copper loss is 0.5 HP again. Friction and windage loss is 0.5 HP. Find the speed regulation. What is the equation for speed regulation? Let's do one. Okay, let's do that. Speed regulation is something. Regulation means is nothing but speed regulation is there is an equation is equal to ns minus n divided by n into 100. If it is divided by ns, it will be slip. You have to focus on that. Okay, equation. If you ns minus n divided by ns means it will be slip. Suppose ns minus n divided by n means what? Regulation. Did you remember that voltage regulation equation? VNL minus VFL divided by VFL into 100, correct? So it will be ns minus n divided by n into 100. We have to find ns, right? We have to find ns. It is nothing but 120 into Fs divided by P. So it will be directly 120 into 50 divided by, how many poles are there? 4. So it will be 3, 30, right? So 1500 RPM. 1500 RPM. So speed regulation will be speed regulation equal to what, my dears? 1500 RPM minus 1440 divided by 1440, correct? Into 100. Into 100. Okay. So it will be 60 divided by 1440 into 100. You will get an answer like, you will get an answer of nearly 4%. Okay? Nearly 4%. It's easy, right? It's easy, no need to explain more. It's direct equation, direct substitution. Okay? So note it down. Note it down. Next you have to find slip. Next you have to find slip. So what is the equation? Simple again. Slip is equal to, or percentage slip you can go, it is very easy. Ns minus n divided by ns into 100, my dears. Ns into 100. So it will become 1500 minus 1440 divided by 1500 into 100. Correct? It will give over, it will be 16 divided by 5. So it will be simply 4%. Simply 4%. Okay, so that is the slip equation. Did you note? Did you note? Okay, can I wrap this? And next we have to find, my dears, what is that? Mechanical power developed. C, mechanical power developed. What is that? PM, correct? Mechanical power developed is nothing but, my dears, PM. Okay. So, did you remember the stator, rotor diagram? I already explained that. Did you remember that rotor diagram? What was that? The power diagram of rotor. Here we injected a power of PG. The rotor copper loss will be S into PG, and there will be a mechanical power developed in the rotor, that is PM, and you have to subtract what? Friction and windage loss there, right? Friction and windage loss there, and the remaining power will be shaft power or P shaft, correct? The remaining power will be shaft power or P shaft. I already explained this, right? So we have to find what? This PM, right? So the connection between these are PM minus what? PM minus friction and windage, right? Friction and windage loss equal to what? P shaft. A 10 HP motor means the output or the available power at the shaft is nothing but, my dears, 10 HP. A 10 HP motor means the output power is called the 10 HP, right? The developed mechanical power, the input power, that we don't want. We want, suppose you are a buyer, you go to a shop and you want to buy a motor. then you don't want to know what is the inside power, what is the mechanical power development and all. We just want, I need this much energy as the output. You are not bothered about the input losses and the input efficiency, or sorry, not input efficiency, efficiency, or simply what power developed, what the friction and windage losses, what is the rotor copper loss. You don't bother about that. You just want, suppose you are a farmer, no? You assume a farmer. Suppose he want a 5 HP motor. A 5 HP motor in the sense, he should have an output of 5 HP. Okay, that means the available or the end result after the all reduction and all, the end result available at the shaft or available in the motor is called the output power or shaft power. So this is equal to shaft power. So what will be the mechanical power developed from here? It is nothing but, my dear, shaft, P shaft plus friction and windage loss, correct? Windage losses will be equal to 10 HP, correct? 10 HP plus what is friction and windage losses? The friction and windage loss is what? 0.5. So it is simply 10.5 HP. If the answer you want in HP means, you can directly give your answer in HP. That's all. See the question's level. Actually the question is very easy, but you have to clearly know what happening inside the machine, what is happening inside the machine. Then only this type of problem can be solved. Otherwise it will be very difficult. Okay, you can't move a single step. If you see this much big question in your examination, read carefully and find your own picture, or imagine your own picture in your mind, then you start solving. Then it will be very easy. Clear? So I think it's clear. Next, what is that? Let's see the next question. That means the next is sub question. Air gap of power, my dears. Next you have to see D section. D is air gap of power. Air gap power. Air gap power is nothing but it is PG, correct? PG. So I'm again saying these all question will not be asked, but a portion will be asked. Suppose you have to directly find air gap power. Suppose you have to directly what mechanical power developed, like that. Like that only question will be expected. Okay. So air gap power. What is the equation for air gap power? What is the equation for air gap power? Okay. How can we find that, my dears? So the relationship between rotor copper loss is that and air gap power is that it is nothing but S into PG. Am I correct? Rotor copper loss will be what, my dears? It is the rotor copper loss, correct? This is called the rotor copper loss. Okay, so this rotor copper loss is nothing but S into PG, correct? So we have to find what? Air gap power. So from that, PG will be equal to what? PRC divided by S, which is equal to, what is PRC? PRC is the rotor copper loss, correct? Rotor copper loss. Is there any rotor copper loss? Is there any rotor copper? Stator copper loss is there, but is there any rotor copper loss? Is there any rotor copper loss? No. No. So this equation, no. PRC, we have to find again PRC, and one more equation is there. Let's go for that. We have to check all, my dears. We have to check all. So air gap power PG. See, what will be the rotor efficiency here? What will be the rotor efficiency here? Rotor efficiency will be equal to, what is that? 1 minus S. What is that? Rotor output. What is the rotor output here? PM divided by rotor input. What is rotor input? This is rotor, my dears. This is rotor. So PM divided by what? PG. That is the rotor output divided by rotor input will give you the rotor efficiency. And we already derived the equation for rotor efficiency, but it is nearly equal to 1 minus S. We can directly substitute that. We have to find what? PG, right? PG is equal to PM, you already have, right? PM, mechanical power developed, you already have. 10.5 divided by 1 minus S, correct? 1 minus S is what? Slip. What slip you got? 4%, I think, right? Yes, this will be 0.4% means it will be 0.04. So it will be 10.5 divided by 0.96. You can directly do and you will get the answer. Okay, it will be, see, in examination these type of point and point complicated division and multiplication will not be there. Easily you can cut and you will find the answer. So that type of question will be asked in examination. Okay, so you can find the answer. So that's for the air gap power. Okay, and let's see the next sub question. Let's see the next sub question. It is nothing but rotor copper loss. Next subsection is what? Sub question is rotor copper loss. Rotor copper loss. How can we find that? Rotor copper loss means it is nothing but PRC. Okay, PRC. How can we find that? How can we find that? If you know the value of slip, if you know the value of PG, how can we find the rotor copper loss? There is a relation I already write, right? PRC will be equal to S times PG, correct? PRC, this is nothing but this is rotor copper loss. This is S times what? PG, correct? So it will be equal to 4 by 100 or 0.04 into PG. What is PG? This much, correct? 10.5 divided by 0.96. Okay, that also you can calculate and you will get the value of rotor copper loss. Okay, direct mean these are calculation, right? We do not want to waste your time by doing this multiplication and division. I think we will get. And what is the next subsection, the sub question? What is the next sub question? Let's see that. Let's see that. F. Next sub question is what is the input power? Input power. Input power you have to find. Input power is root 3 into VL IL cos phi, but IL is not there. VL is there for 50 watt. Directly you can take as VL, but IL is not there. So that equation doesn't match. Then what will be the equation again? In terms of losses, how can we say that? Input power will be equal to, my dears, input power will be equal to what? I can write like this. Input power will be equal to power PI will be equal to how can we write? PG, that is the air gap power or the stator output, plus stator copper loss. We already said stator core loss is negligible and stator copper loss is 0.5 HP. It is given, right? It is given, right? 0.5 HP is given. So it will be equal to PG. What is PG? It is this much, correct? 10.5 divided by 0.96. I am writing in that way. Okay. And stator copper loss is 0.5 HP. These all are in HP, right? You will get the answer. You will get the answer. Okay. And last, efficiency of motor. What is the equation for efficiency? Efficiency of percentage efficiency equal to what? 1 minus S into 100, correct? So it will be equal to 1 minus 0.04 into 100, or simply what? 0.96 into 100, or simply 96%. See, this much efficiency is there for induction motor, and for transformer the efficiency will be 98 or 99 range. But in case of DC motor, we will learn later, the efficiency will be 60 to 70, 60 and 70. That's why DC motor is not, you can't see everywhere. DC motor you can't see everywhere because of that poor efficiency. Lot of losses will be there in the DC motor or DC machine. But in certain application, DC motor is the perfect. You can't replace any other motor with that. It is DC motor because that much efficient will be there in that particular application, right? Height, starting torque and all. Because that type of motors are there, but no, in certain application DC motor is preferable. Okay, so this much is the efficiency of the induction motor. See, 96% efficiency. Only 4% will be lost. 4% will be lost, my dears. 4% will be lost. Super motor, right? You feel it and study. You feel it and study. You simply write, you find 90.96 or 96. Okay, buys. No, you feel it. Oh, this much efficiency. That is the feeling, and You simply mug up, you can simply get mark, you can simply pass the exam and all, no, but you have to feel, okay, this much is, then only that will be more and more interesting, then only the study will be interesting. Otherwise it will be simply mug up and what, vomiting, correct? Okay, so that's all for that question, my dears. That's all for that question. Let's move on to next question. I know these question answer and all, it is actually boring, I know that, but theory is very interesting, right? But we have to do, right? We have to do, then only we can crack the exam, because in examination more and more theory will be there equally, and equally weightage is for problems also. Okay, another super question you have to write. It's also very big question nature, I mean this much will be there. Okay, see, a three-phase induction motor has a 4-pole star connected stator winding, and run on 220 volt, Hz supply. The rotor resistance is 0.1 ohm per phase, and standstill reactance is 0.9 ohm per phase. The ratio of stator to rotor turns is 1.75 full stop. The full load slip is 5%. Full stop. The full load rotor impedance per phase. Full stop. Find. Again, so many are there, and we can do one by one. Okay. So first you have to find rotor impedance per phase. Rotor impedance per phase, we have to find that. Okay. How can we find that? How can we find that rotor impedance per phase? Did you remember the diagram? Okay, turn the pages. Did you remember the diagram? What was that? Rotor impedance per phase is equal to Z per phase, that be Z per phase, which will be equal to, my dears, can I write like this? Simply R2 dash by S plus J into X2 dash. Am I right like this? Turn the pages, you will see this equation. R2 dash by S plus J into X2 dash. Okay. So it will become, what is R2 dash or rotor resistance? Equivalent rotor resistance is simply, you may see R2 dash or Jx2 dash, or simply you can see R2 plus J into X2. No issue, no issue. R2 by S plus J into X2 also you can use. Okay, no issue. So it will be equal to rotor resistance is 0.0 ohm per phase, correct? So 0.0 ohm divided by slip is what, my dears? 5% slip. Am I correct? It will be equal to 0.05 plus J into X2 is what? X2 is 0.9, correct? 0.9. Standstill means simply X2. Suppose it is in running condition means you have to use another term, S into X2. But standstill equation only it contains, right? J into X2 only it contains. So simply you can go for standstill equation. So solve it and you will get an answer of 2 plus j, it is 0.1 divided by 0.0 is nothing but 2 plus j into 0.9. 2 plus j into 0.9. Okay, so that is the rotor impedance per phase. And next, what is that? Next we have to find rotor current per phase. Rotor current per phase. Let be I2. Rotor current per phase, let be I2. Okay. So finding I2 is nothing but, my dears, I2 is nothing but I2 per phase now. So I2 per phase will be nothing but, what is that? Rotor induced EMF per phase, that is E2 per phase divided by Z2 per phase. Am I correct? E2 per phase divided by Z2 per phase. Voltage divided by impedance will give the value of current. But Z2 per phase we already know. What is E2 per phase? Rotor induced EMF per phase. How can we find that? For finding that, it is given stator to rotor turns is 1.75. What is that? Stator to rotor turns is 1.5. So I already told you that induction motor can be considered as the rotating transformer, my dears. It can be considered as the rotating transformer. That means stator winding and rotor winding is there, pretty similar to primary and secondary winding. So we have the equation. We have E1 by E2 is equal to, what is that? N1 by N2. N1 by N2, similar to the transformer. So what do we have to find? E2 we have to find, correct? E2 we have to find. N1 by N2 is already given, right? What is that? Stator to rotor turns. What is that? 1.75, correct? Stator to rotor 1.75. So E2 will be equal to E1. E1 is nothing but the, what? E1 for phase, correct? E1 for phase divided by 1.75, correct? Then what is E1 for phase? What is E1 for phase? What is E1 for phase? E1 per phase. What is that? What is that? How can we find that? See, formula calculation. 220 volt. Run on 220 volt means, normally in the question, the given data will be all in line quantities, my dears. Line quantities. Okay. Normally that is the convention. So all the quantities will be in line. So line quantity is given. It is given that is a star connected stator winding. So in a star connected system, star connected connection, what is the relationship between line and phase voltage? We have what is that? VL is equal to root 3 into V phase. So V phase will be equal to what, my dear? VL by root 3. Correct? So here, what is that? E1 per phase will be, that is phase quantity, that is nothing but 220 by line quantity by root 3. So it will be nearly give the value 127. It will be nearly give the value of 127 volt per phase, correct? So now you have the value of E1 per phase, correct? So you can easily find what? I2. It is nothing but the current, correct? So E2 per phase, my dears. E2 per phase. Sorry, E1 for phase. E1 for phase is the given quantity 127. So E2 per phase will be what? E2 per phase will be what? It's equal to 127 divided by, what is that? 1.75, correct? What is that? 127 divided by 1.75, you will give 72.6 volt. You can do it by yourself. You will get 72.6 volt. So now you get the value of E2 per phase. So it is very easy to find I2 per phase, which is nothing but, my dears, I2 per phase is nothing but, what is that? E2 per phase divided by Z2 per phase. So it is nothing but 72.6 divided by Z2 2 plus j 0.9. Am I correct? So you will get the value of what? You will get the value of nearly 33.14. 33.14 ampere. 33.14 ampere. See How beautifully we arrived the answer. How beautifully we arrived at the answer. See that? See that, my dears? How beautifully we arrived at the answer. Did you get? Did you get? Okay. Can I remove? So you find the value of rotor current per phase. Okay. Rotor current per phase. You find rotor current per phase. Next sub question, rotor copper loss at 5% slip. Next you have to find C, rotor copper loss at 5% slip. How can we find rotor copper loss at 5% slip? How can we find this? How can we find? It's very easy actually. Directly you can go for that. What is that? Rotor copper loss equal to 3 into I2 square R2. Correct? 3 into I2 square R2. You can directly go for that. Okay, so it will be equal to 3 into I2 square R2, correct. So it will be equal to 3. You have all the values, right? You have all the values. 3 is there, I2 square you already have, I2 you already found out, R2 you already have, right? Rotor resistance is 0.0 ohm per phase, no? So rotor copper loss will be equal to 3 times you already multiplied, so you can directly go for that. 3 into, what do you get the current? 33.14, correct? 33.14 the square into R2 is nothing but 0.1. 0.1 ohm per phase, my dears, per phase. So we already multiplied with the 3 now. So okay. You already multiplied with the 3, right? Okay. Correct. So that will be give you the value of nearly 329. It will be equal to 329. No, yes, correct. 329 watts. So that is the rotor copper loss. And next you have to find rotor input. Next you have to find rotor input. Rotor input is nothing but what is that? PG. Correct? If you know the value PRC, then and know the value of slip, then the PG will be equal to what? PG will be equal to what is that? We have the relation, what is that? PRC is equal to S times PG, so PG is equal to PRC divided by S. So PRC is given as 329 divided by S is given as nothing but 5%, so it will be 0.05. So the answer will be 6589, my dears. 6589 watt. 6589 watts. See, did you get the answers? Did you get the answer? These are very easy questions. You can directly apply. You can directly apply. But we have to cover all. We have to cover all. I know you are slightly boring because it's direct question and answer session now. There is no that interesting fact, that interesting explanation is not there, right? So you may feel slight boring, I know that. Okay, anyway you have to you have to what? Adjust with that, right? You have to adjust with that. So let's do another question. Let's do another question. Let's do another question. See, my aim is to cover all the syllabus, right? Cover full syllabus I want to. That's why. Even though the problems are boring, I am doing, right? I know that it's slightly boring, you know. But what we do, you have to do, right? Okay, next question. A 4-pole 50 hertz 3-phase induction motor, rotor resistance, rotor resistance is 0.024 ohm per phase and standstill reactance is 0.6 ohm per phase, and find the speed at which maximum torque developed. Okay, see the question. See the question, my dears. How can we find that? How can we find that? How can we find that? See, a 4-pole 50 hertz 3-phase induction motor is there. Rotor resistance is 0.024 ohm per phase, right? So I can write like R2 is equal to simply R2 is equal to what, my dears? R2 is equal to 0.024 ohm per phase. Am I correct? And standstill reactance is, it is given that is X2 is equal to what is that? 0.6 ohm per phase. Correct? Find the speed at which maximum torque developed. Find the speed at which maximum torque developed. So what is the relation for speed or rotor speed? Simply NR or simply N, which is nothing but, my dears, 1 minus S at maximum torque into NS. Am I correct? Did you remember this equation? General equation for what a rotor speed is that N is equal to 1 minus S into NS bus, and we have to find the what maximum torque speed. I mean the speed at which maximum torque developed means we have to find this slip at maximum torque developed first, then only you will get speed at maximum torque, because 1 minus S, this S stands for slip at maximum torque, this S stands for what my dear? Slip at maximum torque. So first you have to find slip at maximum torque. What is the equation for finding that? Slip at maximum torque will be, let be S max will be equal to, what was the condition for maximum torque? First you derived the slip at maximum torque, right? So S will be equal to what, my dears? R2 by X2. Plus what is R2 here? 0.024 divided by what is X2 here? 0.6. So it will be nearly equal to what? 0.024 divided by 0.6 will be equal to what? 0. Correct? 0.04. Am I correct? Am I correct? So this will be the slip at maximum torque. You can directly substitute like NR or N is equal to what? 1 minus 0.04 into what is NS? What is NS? Synchronous speed, no? Synchronous speed is nothing but, my dears, 120 into Fs by P. P is nothing but what? Kitna pole? 4 pole. So it will be equal to 0.96 into 1500. What is that? What is that? 1440. Which means normally a 1500 RPM machine normally runs at, my dears, 1440 RPM. It is almost no. It is always it is like that. For 1500 RPM machine, the rotor speed will be nearly equal to 1440 RPM. So this type of question may you expect for examination directly. You can expect this type of question. You have to think a little, right? Think a little bit before this equation. No, you have to directly get into this. First step at the first instant itself, you have to remember this equation. Otherwise, you may stuck. Okay, so that's all about the question. Can I rub this? Can I rub this? Did you know this? Did you know this, ideas? Okay. Right, another question. A three-phase induction motor changing the starting torque, changing the starting torque, First, you have to find the changing starting torque when supply voltage is increases by 10%. Okay. A three-phase induction motor changing starting torque, first you have to find this answer, and sub questions are there, okay, similar to the previous question. So first sub question is when the supply voltage is increased by 10%. Question is nothing but what will be the changing torque, starting torque, when the supply voltage increases by 10%. Okay. How can we do that? How can we go for the answer? Let initial voltage be 1 volt. Anyway you can assume initial voltage be 1 volt and final voltage will be what? Final voltage will equal to, or final voltage simply equal to what, my dears? Increases by 10% means final voltage will be 1.1 volt. Am I correct? Percentage in terms of percentage, what is the 10% increment of 1? It is 1.1, correct? 0.1 is the percentage increment, 10% increment of 1, right? 0.1, correct? So it will be 1.1. We have torque proportional to what, my dears? V square. We have the equation, right? Torque proportional to starting torque. We derived the equation, so many equations, right? T proportional to V square, we derived, no? So T proportional to V square apply, what I get? Percentage change in torque will be equal to what, my dears? T proportional to what? V square. V square is nothing but final V square minus initial V square. Final V is 1.1 square minus initial V square is what? 1 square. So this much torque will be changed. So it will be equal to, proportional to what? 1.21 minus 1. So percentage means it will do 100, correct? So it will be equal to 0.21 into 100. So the answer will be equal to what? Which will be equal to 21%. What? Increase or decrease, my dears? Increases by 10% now. So it will be increases by 21% increases by. The answer will be 21% increase. This question now several times I think you may notice, you might have noticed in your examination, but most of the time we will get the wrong answer. The concept is here. This is the correct way in which you have to take the concept. Let initial voltage be 1 volt, final voltage be 1.1 volt, then it will be what? 21% increase. Correct? Did you get the answer? Did you get the answer? And what is the second session? What is the second sub question? When the supply voltage is decreases by, second sub question is when the supply voltage is decreases by 4%. When the supply voltage is decreases by 4%. How can we find that? Same manner, initial voltage will be equal to 1 volt. Final voltage will be equal to what, my dears? Final voltage will be equal to 1 minus 4 by 100, correct? Supply voltage is decreases by what? 4% means 1 initial voltage minus it is decreasing, so minus 4 by what? 4 by 100. So 1 minus 0.04, which is nothing but, my dears, 0.96. So final voltage is what is that? 0.96 volt. So percentage change in torque will be equal to what is that? How can we write that? 1 minus 0.96, correct? 1 square minus 0.96 square, correct? T proportional to V square, right? So 1 square minus 0.96 square into 100. It is actually final is 0.96 now, so you can write that way. Final is 0.96, right? 0.96 square minus 1 square into 100. So it will become nearly, you will get 8% decrease, because voltage is decreasing now, so definitely torque will be decreasing. And how much percentage? 8% will be the decrease. You solve it and you will find. And three sub question. Voltage increase by 4 times. Voltage increase by 4 times. So it will be 5 times. Voltage increase by 5 times. 5 times. What will be the percentage change in starting torque? Starting torque will be equal to what, my dears? 5 times means what will be? We have this, you have to find T proportional to V square, correct? T proportional to V square. So it will be 25 times, right? 5 square means 5 times and 5 square means 25 times V square. So the starting torque also percentage change in starting torque equal to 25 times. Okay, you can do in simple, another means direct steps, no expanded step. You can write, let be T start 1 be the initial starting torque, which is proportional to V1 square. Okay, you can assume that, sorry, V square you can assume, and T start 2 will be proportional to what? 5 into V the whole square. You can say like this. And T start 2 by T start 1 will be equal to 25 V square divided by simple V square. V square and V square get cancelled. T start 2 equal to 25 times T start 1. This also you can write. T start is equal to 25 times T start 1 bus. Every question you can solve in that manner also. Next, for voltage decreases by voltage, but my dears, decreases by what? 4 times. So what will be? Decreases by 4 times means definitely torque will be decreasing, right? Torque will be decreasing. That will be the first instant you have to think about. Okay, so it will be equal to what? Again, let be T start 1 will be proportional to V square. Okay, let be T start 2 will be equal to, again, proportional to V square means 4 times it is decreasing. Okay, 4 times it decreasing. So let be voltage is 4 times decreasing now. 4 times decreasing now. So V by 4 V square. Am I correct? So we can write like T start 2 divided by T start 1 will be equal to what is that? V by 4 the whole square divided by what, my dears? V square. So it will be, or T star to 2 will be equal to T star to 1 into 1 by 16, or simply T star to 1 by 16. So 16 times it is reducing bus. 16 times it's reducing. Okay. Here you go for the initial voltage minus final voltage square. Here also you can go for initial voltage minus final voltage square, but division is very easy, right? This type of division is very easy. So 16 times it is reducing. So I can say that T star to 2 decreases by 16 times, correct? Here it is increases by, T star 2 is increases by 25 times. Here it is decreases by 16 times. So in this manner also you can solve. In this manner also you can solve. Did you get the idea? Did you get the idea? So correct? Correct, my dears? Okay. So that's all for today. So let's continue with the new session on tomorrow. Okay. So bye. Take care.